We present Recode, a lightweight find-and-replace interaction in the IDE for transforming code by example. I'm Nemo, PhD student from Carnegie Mellon University. This is joint work with colleagues at Microsoft. Say we're replacing the name of a function. For one line of code, just select and type. Easy. Multiple lines gets a little tedious, so we'll use find and replace. Oh, be careful about not replacing a comment. We could also use the rename refactoring in the IDE. In this case, we are consolidating two function calls into one. The code calls expect with A and then to equal with B. We want to change it to a single call to same with both A and B as arguments. For multiple lines, there's no refactoring tool for this kind of change, and find and replace won't get us very far because every line is slightly different. These four lines only share common keywords like expect and to equal, but our change involves moving the arguments around, so we're doing it manually instead. Just like what we did, developers frequently perform repeated systematic code transformations on similar but not identical code to refactor the codebase, migrate to new API, adopt new coding style guidelines, and so on. These code transformations can frequently be repetitive and sometimes edit thousands of files. When there are only a few lines of code to transform, it doesn't take much time to do them manually. When there are hundreds and thousands of files though, writing a robust code transformer, which can take hours, is worth the investment. How about something in between, say 50 changes across 10 files? Manually making the changes is both time-consuming and error-prone. We could use macros, multi-cursor mode, or regexes, but which one to choose? This is the murky middle that developers frequently found themselves in, where lightweight automation can provide a lot of benefit. In this murky middle, there are a lot of tools to choose from, but which one applies to our situation? And which is worth the uncertain time investment? In short, developers face a decision paralysis and often default to manual editing instead. In our formative interviews, participants express desires to make code transformations by editing files directly and have the editor apply it elsewhere automatically. Let's revisit our example. What if we can make one change to any line that needs to be transformed, but this time, the editor knows what we want to do and intelligently suggests edits to us? Instead of a macro that just repeats our actions naively, the editor actually understands the code transformation at the language level and performs an appropriate edit to each line. This is what Recode does. Let's look at the way a developer uses Recode in detail. In this scenario, the developer wants to upgrade from JavaScript ES5 to ES6 for their React website. One new feature in ES6 is arrow function. The old code in the site have these bind calls in the constructor. The goal is to remove it and change the corresponding member function below to an arrow function. To initiate the interaction, the developer first finds potential locations to change. The search term doesn't need to be precise as long as it gets them to all lines of interest. In this case, the developer types bind. Find is a natural entry point for Recode because developers already do this every day. They frequently search for short keywords in find as a way to navigate the codebase. For Recode, the find results communicates a rough scope of code transformation. For developers, it's a workspace for bookkeeping and planning. After clicking on the keyword match in the result view, the developer then directly makes a change in the main editor, deleting the bind call for change tab and changing change tab below to an arrow function. Notice that this change goes beyond the line with the keyword match and spans multiple lines in the current file. Recode treats the edits to both lines as one positive example of code transformation and generalizes it to other matches in the find result. Internally, Recode synthesizes a program for this transformation, which performs the change generally at the abstract syntax tree level. Once the transformation is synthesized, suggestions are displayed in the result view as yellow highlights, and inline as diffs and code lenses. The developer can accept or reject one or multiple suggestions. This process is iterative because Recode continues to run in the background as the developer interacts with the suggestions. Recode treats each accepted suggestion as an additional positive example, and each rejected suggestion as a negative example. The process continues iteratively until the developer closes the find view. We performed a usability evaluation of Recode and found that developers successfully completed tasks ranging from simple renaming to complex multi-line changes in under 5 minutes on average. In the follow-up interviews and survey, participants commented positively about their experience with Recode. The tasks appear frequently in their daily work and are tedious to perform manually without Recode. All of them indicated that they would use a production version of Recode. Code transformation is a deliberate activity. Participants appreciated the more active interaction model of Recode as compared to the more passive model of, say, autocompletion. They also commented positively on how Recode fits easily in their workflow of code editing. For in-depth discussion on related work, how the synthesis engine works, and more, check out our paper. Email or tweet at me to get in touch. Thanks for your attention.